Hello and welcome back. So I hope you have already gone through those videos. So let's get to the Wireshark and let's see how our capture looks like. So if I will take you to the next slide, first of all, I just want to give you the overview of IPv6 header. So this is the IPv6 header look like. Okay. So you can see compared to IPv4, we have so many less options in IPv6. So it means it is much more faster as compared to the IPv4. So what IPv6 is having, same like the version, it could be 4 or 6, but in case of IPv6 we have 6. Traffic of class, this is same like type of service in IPv4. Then this is the flow level. This is flow level, same like to make sure the 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 transmission or the packet that we send from source to destination, they are received in a correct order. Okay, so whatever the information we have here should be here. Okay, so that is why we use the flow level. Then we have payload line. This is basically the data. Next header, this is same like protocol. Next protocol. And I told you in case of UDP, it will be 17. In case of TCP, it is 6. Okay. Hop limit. Hop limit, you can correlate it with TTL. Then we have source address and then we have destination address. So let's head over to the Wireshark and let's very quickly capture the packet. So click on the local area connection and I'm gonna use my web browser, and you can see the page refreshed and you will see something is going on. So we have captured the packet. So we are concerned about IPv6. So let's stop this capture. Since you can see the source is from the IPv6 address to the destination IPv6. So let's select this packet and come into the Internet Protocol 6 version. So you can see over here the version is 6. This is the source IP address. This is the destination IP address. You can see over here as well. Source and destination. Hop limit is same like TTL. So you can see it is 62. Next header, this we are, if you want to correlate in section of IPv4, this is the protocol section. And you can clearly see we have DNS. So that is why 17, because UDP, DNS works on top of UDP. So that is why next protocol is going to be 17, which is user datagram protocol. If it is 6, you will see, if I can show you over here, this is 6 because the next protocol is TCP. Okay, so the UDP is here. Now you have better understanding about next header. Then we have payload line. This is the size of the data. Okay, so this is it. And this traffic class, the same like we have talked about here, the traffic class. So whatever we said, you can visualize in the Wireshark as well. Okay, so let's head over to the next slide, which is talking about from the perspective of cybersecurity or network security. So, currently you haven't learned about the IPv6 a lot in detail. So that's why we are not going to go, you know, discussing about all these issues, in detail because I don't want you to get confused. Just to scratch the surface, since IPv6 we do not have, there are so many people still they are not aware of IPv6. So lack of IPv6 support from the ISP vendors along with IPv6 security knowledge, lack of security knowledge is the number one reason we have security concerns. Then on the third week, you can see logging system and SIEM system may not work properly. So SIEM stand for security, information, and event management. So this is kind of firewall basically. If you can see our ISP and vendors are not supported. So SIEM, of course, maybe if I will give you example of IBM, they have this SIEM kind of systems, okay, softwares, basically to protect our system. If IBM is not aware or they haven't configured IPv6 kind of security implemented in their applications, how we are going to mitigate those issues related to the IPv6 attacks? Okay, so lack of security knowledge, lack of support, and then uh, these days these applications are not IPv6 aware, so this is also another one of the reason. Then bugs in a new code. So whatever the new code appears, for example, some SSH related some applications is developed which support IPv4 and IPv6 as well. But let's say the SSH still, this company, whoever is going to create these applications, still have a lot of bugs in a new code, end up having security breaches. Last but not least, absence of network address translation. So NAT is not there because for the IPv4 we use NAT, then we go to the public infrastructure. But in case of IPv6 we do not need netting. So before we had this one barrier, it's, you can consider it like one security firewall, if you will. But IPv6 is totally clear. There is no any kind of barrier. So that is also one of the reason we could have some security breaches. So I hope you get the ideas. Let's head over to the next slide. From the perspective of cloud, if I will take you to the cloud, so this is AWS Management Console, and if I'll show you the VPC, if I'll take you to the let's suppose your VPC, from VPC ID, and if I'll take you to the under action and edit cider blocks, and you can see we have IPv6 capability as well in AWS cloud. Slowly and steadily they are penetrating IPv6, but this is not pure implementation of IPv6 on AWS cloud, by the way. This is, you can consider it a dual stack. If you're not familiar, you need to search it out. Okay. So AWS totally depend on IPv4 as well. By the way, AWS has also some skill share. If I'll take you to, you can see we have AWS Cloud Administrator Fundamental course, and we have AWS Cloud Administrator Advanced course as well, where we are talking about AWS Cloud, okay, throughout the program. So if you are interested, you can purchase those or you can contact JSS. So common interview and questions. The first is, what is IP address? Okay. Why do we need IPv6 when we have IPv4 available? Okay. You need to answer this question. Difference between IPv4 and IPv6. Why do we need NAT when using IPv6? What is Anycast? Okay, so with that, our IPv6 lecture concluded. So I'm gonna see you in a next video.